Let's look at the question here. So this is the diameter of a circle C1 which has these endpoints. So find an equation for the circle. So whenever we want to look at the equation, it's all about the radius and also the center. Okay. So basically, center is very easy. We just need to find the midpoint. So this is the center of the circle C1. And then if you want to find the radius, okay, it is half of the distance between the two endpoints. Okay, I think this is 100. And then this is 164. Which is a third 41. Yeah. Okay, so the equation. So that is, we get like this is x minus 2 squared plus y plus 1 squared is equals to 41. Okay, so that is what we actually get for the circle here. Okay, so after that, okay, what we actually have in the next part here is that, okay, we are now translating this circle C1 to the circle C2. So as shown in the diagram. So find an equation of the circle C2. Okay, this is a bit of a dangerous here. For this question, we might overthink. Okay, we might overthink that this is something related to the translations in the function. So what happened in the translation in the function is that we might think of, okay, the translation here has got the positive 8 in the x direction. So here the x must be changed to like x minus 8 like that. And for the 4 here, we might think that, oh, the fx now will become like a fx or the y plus a 4. But this kind of the transformation, right, works only when we have got like something which is like a y is equals to like fx like that. So it will be fx in terms of like, I mean, fx is some function in x, or fx is equals to some, I mean, y is equals to something which is in terms of x there. It works like that. But because the circle here is a bit different, because in the circle here, we have got some implicit relationship which is involving the x and y there. So we can't overthink about this one. Super dangerous. So the easiest way or the most straightforward way for us to actually look at it is when we translate the circles, we are actually translating the center. So the C1 has got the center, which is like a 2, -1, right? So when we actually want to translate that, it is like a 8, 4. So it is like 8, 4. Okay, so the center becomes here already. Because it is just translation, the radius is unchanged. So from here, we can look at the center of the C2. Okay, now it has actually become a 10 and then 3. Sorry. So plus 8 to the x coordinate plus 4 to the y coordinate. So we get a 10, 3. Then the equation will become x minus 10 squared plus y minus 3 squared is equals to the radius is unchanged. So it is still a 41 for the radius here. Okay. So the next part of the question actually asks about the two circles intersect at points R and S. So show that the equation of the line RS is this. So basically is to find the intersection from there. So we have to equate the two equation. So we have got like x minus 2 squared plus y plus 1 squared is equals to, what is that? Another one here is x minus 10 squared, y plus 3 squared. Okay, of course, you can actually expand everything very easily from here. Okay, not really an issue for us to actually try to do that there. Okay, shall we just expand? Yeah, I think it's easy if you just expand from there. So the good thing about this when we expand is that the x squared and y squared term will definitely be cancelled off. We just have to like work with the x and the y terms there. So basically, it's just a bit of like simplifying and things like that. Okay. Wow, so many mistakes that I actually made here. Okay, I have to be careful. So of course, after that, when you actually simplify, right, you should actually get the equation lah. That is actually like we want to prove it here. Okay, so you get this for sure. Okay, and then hence show that the x coordinates of the R and S satisfy this equation. So that is like, okay, that is like we already say that, okay, we already say that the RS is actually on a certain line. So we want to find the x coordinate of that. So it is like we are using this equation of the line to intersect with either of the circle. So basically, is to actually sub in this relationship. So it's like y is equals to negative 2x plus a 13, right, into either C1 or C2. Okay, so let's say eventually make use of the equation for the C2 from there. So the C2 here is x minus 10 squared plus y minus 3 squared is equals to 41. So just sum in the y inside there. The y here is negative 2x plus a 13. So after that, you could just expand everything from there and you can actually get the quadratic. Okay, so you just add it up. So 5x squared Oh, okay, sorry. This one is a 10. Okay, so yeah, that's it. There, this is the coordinate x coordinate for the R and S. We just have, I mean, they don't ask us to solve it, and if we actually solve it, we can really get the x coordinate from that. But they just don't need us to actually do that. Okay, so this is the part D. Okay, right. Okay, okay, let's look at the question, the next one. Okay, this is from the May June 20, which the exam never happened. Okay, so for this question, they don't give us any of the diagram here. Okay, so this is actually we have the points, okay, A and B. And they tell us that okay, the A and B here is a diameter, and then we need to find the equation of the circle here. So it's the usual thing, okay, that they can actually ask for the circle. So basically um, for the earlier parts of the questions, right, is as long as we are clear with like how a circle looks like, then we should be actually able to find the equation of that already. Okay. So nothing much is to find the center. Center is just like the midpoint of the two endpoints. Okay, and then we need to find the radius. So the radius is half of the length of the diameter. So inside there is a 64 and a 36. So the radius is a 5. So the equation is, okay, so we have x minus 3 squared plus y minus 1 squared is equals to 5 squared, which is a 25. So remember the r should be squared. Okay. So after that, what we have in the next part of the question, wow, they give so many space for this. Find the equation of the tangent t, okay, to the circle C at the point B. So this is also some very usual question, is to ask us to find the tangent line. So basically, for this kind of the question, it will be the best if I actually try to sketch it out so that everything is actually very clear there. So just forgive my very ugly working there. So this is 0.31, and then let's say we have got this is a point B here. We are supposed to find this tangent T here. So for the tangent, it's always about like we want to find the perpendicular thing from the radius. Okay, the tangent is perpendicular to the radius, and we know that the point B is actually a 7,4. Okay, so we can actually find the tangent from there. So the tangent from the center to the point B there, of course, we can use like y2 minus y1 divided x, that one, x2 minus x1. So this is 3/4. Okay, so the gradient of the line tangent is negative 4/3. So for the tangent line, we can use a y minus y1 is equals to m x minus x1. So any equation, any form of the equation will do that from there. 28/3 plus 4, this is 40/3. Okay, some usual question there for us to actually find the tangent from there. Okay, so the next, so find the equation of the circle, which is a reflection of the circle T in the line T. So how is it like being reflected in the line T? So that is where we've got something like this, and we have got the reflection of it. Okay, so when we actually talk about the reflection, and we're actually trying to find the equation of the circle here, right? So it means that, okay, the center here is a 3,1, okay, and then for this one is actually a 7,4. This is our point B, which is a 7,4. So basically, when it is a reflection, means the distance here should be the same. So it means that the B here should be the midpoint of the two centers. Okay. So we can just make use of like the property where the B is a midpoint of the two centers there, because it is being reflected at the line T there. So let D be center of the reflected circle. Okay, so D, we let it to be say xy. So we actually have got like 3 plus x over 2 is a 7, and also like 1 plus y over 2 is actually a 4. So the x here is a 11, y here is a 7. So the equation of the circle x minus 11 squared plus y minus 7 squared is equals to, so the radius is unchanged because it is being reflected. So this is our equation of the circle. This is the equation. So we want to find the radius and also the center. So it is to use the completing the square for this one. Okay, so for this, we know how to complete the square very well. Let me just write the complete the square here straight away. So we can actually get the answer here already. So the radius is 5, the center is 4 and -2. No issue on doing this as long as we know the complete the square and the form of the equation of the circle. Okay, it's something that we need to know in mind, okay, for the equation of the circle. One thing that is easily like to make mistake here, it's always a right hand side. The right hand side is always a r squared. Okay, when they ask for a radius, we need to square root that first. Okay, so should be no issue for the first one here. Let's look at the second one. The point 1, 2, okay, lies on the circle. Show that the equation of the tangent at P is like 4y is equals to 3x plus 5. So this is even like given. So we have found our center. So it's actually depending on our center lah. So 4, -2. And we have got another point which is like what is that? 1, 2. So let's say this is our P, which is 1, 2. And we want to find this tangent line here. So first is to actually find the gradient of the tangent for the CP here. So to find that, we get this is a -4/3. So the gradient of the tangent. So this one you should already know how to do it very well lah. Okay, so this is the gradient of the tangent, and we actually look at the tangent line. So y minus the y1, the tangent pass through the y coordinates 2 equals to m, and we have got x minus x1. x1 is a 1. So just rearrange from there basically. Okay, it's a usual question that actually asks about the tangent there. So no issue for this one. Okay. So the point Q also lies on the circle, and PQ is parallel to the x-axis. So write down the coordinates of the Q here. So it is actually write down, right? Write down means we don't even need to show extra working from there, okay? So we will actually look at like the case that, okay, if they say PQ is parallel to the x-axis, so it means that the PQ is actually horizontal like that lah. So this is sort of like our Q here. So when I actually draw the P here, I also sort of like consider where is the coordinates, yeah, roughly. So 1, 2 should be actually at here, and this is our 4, -2 like that. I also sort of like consider that correctly already. Okay, so to actually like have the coordinate of the Q here, right? If it is horizontal for the PQ, it means that the Q should have the same y coordinate. So the Q here should have the y coordinate of 2. So what about the x coordinate? So if the x coordinate here is like, okay, you can see from P to C here, the distance is like 3, right? So it means from C to Q here, the distance here should also be 3. Okay, so the Q, we actually have got the coordinate of the 7 for the x there. Okay, so they just want to see like the x and the y coordinate. It's 2 marks here. Okay, the 2 marks is given to x 1 mark, y 1 mark. Then you can get the 2 marks here already. Where by actually doing a little bit of like a simple sketching here. So the sketching here is really important to help us to identify a lot of the things from there. Okay, it really helps. Okay, so okay, this is the thing. The tangents to the circle at P and Q meet at T. So find the coordinates of the T. There are different ways that we could actually look at this situation here. Okay, so how many marks is this? Okay, 3 marks. So you can see that, okay, this is the circle, this is the C, and then we have got like the P and Q like this, right? So if we actually have got their tangent, so what happened to that tangent here is they are like this. And we also know that this is actually the perpendicular. So T, right, will surely be having the x coordinate of the C. Okay, the T will surely have the x coordinate of the C here because of the property, because P and Q, they are sort of like symmetry about the vertical line there. So the t here will actually surely be taking the x coordinate of the c here. Okay, and other than that, okay, how do we actually find the y coordinate? There are actually different ways for us to actually look at it. If we know that the x coordinate of the t is actually taking the coordinate of the c, right? The c is 4. Okay, then to get the y coordinate of the t, that is like we use the line. So because we know the tangent line, which is the p already, so the tangent line is 4y equals to 3x plus 5, right? So we now know that the x coordinate there should be a 4. So this is a 17 over 4 for the y here. So the t is taking this coordinate here. Okay, that is the quickest way for us to actually identify this. Because I guess the 3 marks, which is actually like given in this case, right, it could be identifying the x coordinate is a 1 mark, trying to sub in the value into the tangent line 1 mark. Final answer correct is 1 mark. Okay, this is how they can actually award the marks here. If not, if you never think of like this idea here, you could really go and find out what is, because you have the point Q already, you can find out what is actually the tangent line at the point Q there and intersect the two lines. Then you can also get the coordinate of the T as well. Okay, but this is the quickest way for us to actually like find this coordinate here. Okay, so this is the two coordinates, okay, they gave us like the points A and B here. So we need to show that the equation of the perpendicular bisector of the AB is that 3x plus 2y is equals to 11. So a few things that we need to find. Perpendicular bisector will pass through the AB. So we want to find the perpendicular bisector to it, okay? So let's say if we actually have got like this point, let's say we give this point as like, let's say point P here, okay? So it's perpendicular bisector. So we will let the P be midpoint of the AB here. So let's find out what is actually that. So the midpoint is we just have to add the 2 points like the A and B there, just add them together. Then we can actually get the point. So the P here is actually a -1. Okay, sorry, this is a 2. So -1, and then we have got a 7. So this is the midpoint. And also we need to find the gradient first. So the gradient of the AB is we actually have 11 minus a 3 divided by 5 minus a -7, which is 8 over 12. It's a 3 over 4. So with that, okay, the gradient of the bisector is -4 over 3 in this case. Okay, so the perpendicular bisector we actually have like the y minus, so the point that it passes through is the 7 is equals to the gradient of the bisector, because it is actually like a 90-degree multiplied by x minus the x1. So from there, we just have to tidy up. So you get 3y minus 21 equals to -4x minus 4. So let's see what is the form that the question wants here. So 3x. Okay. Okay, this is a 2 over 3, sorry. And then this is a -3 over 2. So we get 2y minus 14 is a -3x minus 3. So the form that they actually want us to give is like in like 3x plus 2y is equals to 11. Okay, so that's our perpendicular bisector. So what is this perpendicular bisector has to do with the rest of the question? Is that, okay, if you look at the another part here, the part B here, So that circle passes through the A and B, and the center lies on the line, which is like a 12x minus 5y is equal to 70. So find an equation of the circle. So this idea here is to actually use a little bit of the geometry. So whereby we actually have got like the situation. Okay, so let's see what are the A and B first. AB is negative 73, and also we have got 511. Okay, so let's say the AB is like this lah, just roughly do that. Okay, and then just now we have already found out what is actually the perpendicular bisector of the AB. Okay, like that. And the center, okay, of the circle actually lies on this line. So this line is actually like 12x minus 5y is equals to 70. So let's say this is the line, which is like 12x minus 5y is equals to 70. So in order for us to actually get the equation of the circle, we need to have the center. So because if we have already found out what is the perpendicular bisector of the AB, right? So we know that the perpendicular bisector of a chord, okay, the perpendicular bisector of a chord in this case is an AB, will pass through the center of the circle. Okay, this is one important property from the circle that we need to know from that. Okay, chord, when we have perpendicular bisector, it will pass through the center. Okay, so the center also pass through that line, which is like 12x minus 5y is equal to 70. So that is where we are actually going to solve the equation simultaneously. Okay, so we have got 12x minus 5y is equals to 70. And then another equation that we have is 3x plus 2y is equals to 11. So of course here you can choose to do anything that you like from there, including like solving like simultaneous, or you just sub one equation into the other. It's up to you. So maybe we can use like the first equation here to minus like 4 times of the equation 2. So that is actually giving us that is a negative 13y is actually 36. 26, sorry. So the y is negative 2. So the y is equals to negative 2, so we can solve the x from there. So 3x minus 4 is equals to 11, so the x here is 5. So the center is having the coordinate, which is like a 5, negative 2. So, okay, we also need to actually find out what is actually the radius here. So the radius is, okay, we are using the center, and we actually find the distance of the center to the either point, the A or the B there. So we can actually use the distance. So let's say if you make use of like the point B here, so B is a 511. So we have 5 and 11. So it's a nice 13 actually. The center is also a 5. Okay, so the radius is a 13, so the equation of the circle is, okay, x minus the x coordinate squared plus y minus the y coordinate, which we get by y plus 2 squared, is equals to 13 squared. You can leave it as a 13 squared if you want to square that. Okay, so that is the equation of the circle. Okay, so this tests us particularly on a certain rules or the geometrical property that we know from the circle from there. Okay, so we can't actually like forget about all these properties, right? Okay, so this is another question. Okay, October, November 2020. This is also a question that is also very interesting. Let's look at it. The first part, okay, it's very special. So they actually asked us to show that the point T is actually outside the circle. So what can we actually do from there is that, okay, we want to show that it is outside the circle. Outside the circle as in, if this is a circle, right, we want to prove that the T is actually outside there. So what can we actually do from there is that we can actually make use of the idea of the distances. Okay, so here the Okay, we cannot, yeah, the C. So C is the center, right? Okay, so here we're actually finding the C is like 8, 4. So this is where the center of the circle is. And we try to find the distance of the CT. So the CT is actually like, okay, we use like 8 minus negative 6 square plus 4 minus 6 square. Okay, so this is a 14 square, 196, 200. Okay, so this set 200 here is actually like, we can actually write it as a 10 set 2, which is greater than 10. Because, okay, what happens is that the radius of this circle is 10, okay? And then when we actually look at the distance from the T to the C here, it is actually greater than the radius. So it can't be anywhere on the circle, or it can't be anywhere inside the circle. Okay, so you can say that because CT is, okay, CT is greater than the radius. So T is outside the circle. So this is quite an interesting question to it. Okay. Okay, let's look at the part B then. So two tangents from T to the circle are drawn. Show that the angle between one of the tangent and the CT is exactly 45 degrees. Okay, so this is what happened to this situation here. Okay, so that is we have got, okay, if you look at the diagram that we actually have earlier, it looks like this. Okay, now if we actually sort of also like look at the coordinates, yeah. So roughly, if you follow the coordinates there, right? Okay, this is our C, which is 8, 6, and our T here is, what is that? The T here is negative 8, 4. The T here is negative 6, 6, which is like roughly here. 8 outside. Okay, it's roughly here. Okay, this is the point T. So when we actually draw like the two tangents to the circle there, so this is what happened, okay, to the two tangent lines there. So of course, it actually touches the circle. Okay, it actually touches the circle nicely like this, and another one would be like this. Okay, so we also need to recall what do we actually have in the property of the tangent there. So the tangent there is actually like we have got a 90 degree with the radius. Okay, so this is what we get. And what happened is we want to find the angle between one of the tangents and the CT is exactly 45 degrees. So we could actually make use of this. Okay, we can actually split that into two similar triangles. So from here, the angle, let's say we call that as the theta. So it's very easy for us to actually find the theta there, right? Because what happened earlier was that we actually have got like the CT is actually like a 10 set 2, sorry. So if we want to find the angle here is we can actually use a sine. So the sine theta is actually like opposite divided by the hypotenuse. So the opposite is a radius divided by the hypotenuse. So the radius is 10, and we have got like 10 sub 2 for the CT. So it's actually a 1 over sub 2. So therefore, the theta that we have here is a 45 degree. Okay, again, they actually test us on our understanding about these tangents with the point which is outside the circle there. Okay. So after that, okay, what is the question which follows by that? Is that, okay, now the two tangents touch the circle at the A and B. So find the equation of the line AB. Give your answer in the form of like a mx plus c. Okay, so let's see how to actually work on that. Let's say we copy a little bit, yeah, this diagram, so we can actually use it later then. Okay, so the point, okay, that the two tangents touches the circle is the A and B. So let's say this is our Say this is our A here, and let's say this is our B here. Okay, so in that case, right, if we already have found out that the angle is a 45 degree from there, okay, and in fact, the A and B, right, it's actually a straight line. Okay, we can actually join the AB with a straight line here. Okay, so this is how it looks like. Okay, and once, okay, you can see that when once we actually join the AB with a straight line, right, it would be actually having this is like a 90 degree with the this line CT here, and it also has got the 90 degree with this line CT here. Okay, automatically we also know that the other angles here would be like a 45 degree. Okay, so it is actually sort of also like helping us about like how to actually find the line AB here. So basically, we need to first find out the gradient of the CT. So the gradient of the CT that we actually have here is that we can use like a 4 minus 6, and then we use the 8 minus negative 6 here, which is negative 2 over 40, which is a negative 1 over 7. So automatically we know that the gradient of the AB that we have here is 7. Okay, so that actually gives us the gradient of the AB here already. Okay, so that's the first step that we actually found out the gradient from there. Okay, so here's another thing that we need to consider already. So we have got the equation of the line AB, right? It means that we need to find out either the point A and point B, then only we can actually like find the equation from there. Okay, so that's where we actually need to find out what is the A and the B here. So if you actually look at the all the situations that we have earlier, right? Let's see if the earlier situation is actually trying to help us a bit. So for the first one, it is just to show that the T is actually outside the circle. And for what we have in the second one here is, okay, we have already shown that the CT, okay, with one of the tangent line there is a 45 degree. So we actually look at this situation here. So we actually have got the situation where that is like we also have some idea, okay, whereby we can actually find out what is actually the distances. Okay. If you look at like the T here, and also we have got like the point A and also the point B here, they're actually in this relationship. So this is like, wait, this is the C. Okay, so they're actually having this kind of the relationship there. Okay, so we could, I mean, here we need to actually think of a way on how do we actually find the A and also the B here. Okay, so we can actually see, right, for this part here, my figure here is actually not so nice. Yeah. Okay, if this is like 45 and a 45, right? So supposedly here it's a 90 degree. Okay, this is a point T here. Okay, and if we also found out that, okay, this part is a 45 degree. Okay, here is also a 45 degree. So it actually works like a square. Okay, it works like a square here. So if it actually works like a square here, it means that the A and B, right, okay, the line AB, right, will also pass through the midpoint of the CT. Okay, AB pass through midpoint of CT. Okay, so you need to be clear about this one, yeah, because this is actually we use the geometrical property, okay, from all the things that we actually see from there. Okay, so you can see, should I actually draw this the figure nicely for you? Okay. Okay, let me just draw a nicer one for you, yeah, so you can see for this one here. This is a bit messy. If it would be easier to see if you actually turn everything into something like this. We turn a bit, yeah. So let's say this is our AB, right? Okay, and then this is our T, right? Okay, this is our C. So it gives us something like this. Okay, and then this is how the CT is related to, okay, 45, 45. Okay, and then AB, when we actually draw a line here, so this is a 45, so here it should be also a 45 as well. So you can see that, so the AB will actually cut the CT in half. So the line AB will actually pass through the point, which is the midpoint of the CT there. Okay, this is to actually look at it from a lot of the geometry from there. Okay, so if you actually find out the midpoint of the CT, so let's say we let G be midpoint of the CT. So we find out what is the D there. So the midpoint of the CT is just we need to add the C and the T. Okay, so the C is 84, and then the T is negative 6. So the D here is actually like we have got 1 and 5. Okay, so if you have got the D is actually 1 and 5 here, we can actually find the line AB. So the line AB is actually like y minus y1 is equals to m. The m is a 7, x minus x1. So this is the equation of the line AB. Okay. So after that, okay, is to find the x coordinate of the A and B. So the x coordinate could be easily found if we already have got this relationship. So we can actually substitute this y is equal to like 7x minus 2 into the equation of the circle to actually solve that. So the equation of the circle is x minus 8 squared plus y minus 4 squared is equals to 100. So we just sum in the y here. X minus 8 squared plus the y is a 7x minus 2 minus 4 is 6 squared equals to 100. From there, you just need to solve the quadratic here, then you should be able to actually get like the value for the x here already. Okay, so that's how you actually look at it. Alright, so for this year, the question is slightly special, yeah? So you can actually just do it on your own now. Okay? Alright, let's look at the question from other years. This is, okay, this is the March paper again. So it's to find the equation of the circle, given that we have got like 3 points on the circle. Okay. For this, right, okay, it is actually like they gave us the point which is actually like quite nice in the sense that, okay, it actually have like something like this. So if this is our circle, if this is the center, right, so let's say like, okay, let's say we just simply like put those the points A and B. So the points A and B that we have is that, okay, you have like the point A, which is a 7, 1, point B, which is a 7, 9, okay, and then you also have got like point C, which is a 1, 9. Okay, it's actually quite nice that you can see that it is actually something like this. The BC is actually like a horizontal, and then the AB there is actually like a vertical. So with this, it is accepted that we are using, it can be accepted that we are using this property where the center is like the midpoint of all the like 1 and the 7, and also the 9 and the 1. Okay, so for this, okay, we will just let say the F, okay, to be the center of the circle. So let's say the F here, we actually give it like a X and Y lah, that we want to find out. So the X coordinate, okay, is basically considering the 1 and the 7. So the average of the 1 and the 7 is 4. For the Y, the average of 1 and 9, which is we get a 5 here. So the center is having the coordinate of 4, 5. Okay, so the radius, once we get the center, we just use any point to minus. So let's say if we use the 4 minus 1 plus 5 minus 9. Let's say we use the FC. Okay, so this is actually a 3 squared 9. It's actually a 3 square and a 4 square, right? Okay, it's a 5 then. Okay, so this is the radius. Then after that, the equation of the circle is x minus the x coordinate square plus y minus the y coordinate square is equals to the radius square. Okay, so SCC as that. So this is the the equation of the circle. All right. This is the situation where they gave us the points, which is very nice like this. Okay, then only we can actually use the property of like the center or the midpoints to actually find the center of the circle. In other cases, if they just give us some random points, right? Random 3 points, right? In other cases, I just need to remind you about that theorem or the property. If they give us some random points like this, okay, let's just don't put it at the, okay, just put it here. Okay, if they give it just some random points like that, which are not like horizontal or vertical, when we join the 3 points, we need to use the property where the perpendicular bisector will actually meet at the center of the circle. Okay, so we really need to find out the perpendicular bisector of the, let's say AB or BC, or you just use any 2 points to find 2 perpendicular bisectors from there, then you intersect them. Okay, then only we can actually get the center of the circle here. Okay, but like I said, this is because they give us a very nice points. So we can actually use all the midpoints to find the center of the circle. Okay, other case you need to use this, right? So nothing much. Okay, so let's look at the next one. Find an equation of the tangent to the circle at B. So this is also something that we also like know how to actually like do it already. Okay, so I'll just keep this part. You already know how to do this. Okay, they actually like always like to ask this tangent. Okay, let's look at the other questions. Okay, so we can see some interesting question here. They gave us this diagram. Okay, so let's see what is happening there. So the diagram shows a circle with this equation, and the tangent to the circle at a point P, which is a 5, 4. Okay, they already give us the point 5, 4. So the tangent to the circle at P meets the x-axis at A and the y-axis at B. Find the area of the triangle OAB where O is the origin. For this, okay, it is just like the usual situation. Okay, that is, we need to find out what is the equation of that tangent line. So without the equation of the tangent line, we can't really find out what is the x and the y intercept for the tangent line. So although it looks very complicated in this diagram here, but in fact it is not. So basically, that is to actually start off with the equation of the circle. Okay, so we can just rearrange it. So x squared minus 6x plus y squared plus 4y is equals to 27. Complete the square for both the x and the y there. So we get this is x minus 3 squared plus y plus 2 squared is 40. Okay, so we want to find the tangent line. So the tangent line is actually that we have got the, okay, let's say we call it as a center here. The center is C. with the center is like a 3, -2. So the center is here. So first we need to find the gradient of the CP. So the gradient of CP here is -2 minus 4, 3 minus 5. That is actually a -6 over -2, which is a 3. So the m of the tangent is -1 over 3. So really form the equation of the tangent from that. So y minus y1 is equals to m x minus x1. Okay, let's just give it in the form which is like this. So we get x plus a 3y is equals to a 17. Okay, so from there, okay, we have when x is equals to 0, the y is actually 17 over 3, negative, and 17 over 3. When y is equals to 0, the x is a 17. So we have got the points already. The B is the y-intercept. So the A here is the x-intercept. Right? So just find out what is the area. Area of the triangle OAB is just half 17 over 3. So you can get the value from there. Okay, so that's how we find the area of this triangle here. So nothing much from there actually. So it looks scary, but it is actually nothing much from there. Okay, we just need to find out the tangent line for this question here. Okay, so what goes next? So points Q and R also lie on the circle such that the PQR is an equilateral triangle. So find the exact area of the triangle PQR. Okay, so why suddenly we have got this kind of a thing here? Okay, let's see. That is, okay, we have got the PQR. Okay, so they actually have like this PQR here. So we actually want to find the the area, okay, of this PQR. Okay, so what is actually happening is that, okay, if we have got the PQR is an equilateral triangle, so what we can actually see is, okay, this is the equilateral, this is equilateral triangle. Okay, so in this case, they never give us any coordinate about the Q and the R here. Okay, so if they, of course, if they already give us like the Q and the R here, we could easily find the area from there. Okay, but what is the the property that we are actually going to rely in this case is that we're going to be a bit more creative. Okay, that we are trying to split this triangle into like 3 parts. Okay, so okay, let's see. So for this situation here, maybe we could actually consider doing the triangles like this. Okay, we could actually split the triangle into something like this that could actually help us in finding the area. Okay, so we could try to find out what is the say the length of the wait, let me just see. How many marks is this question? It's 3 marks only. Oh, okay, I know how to do that already. Okay, it's okay. Okay, should I do that? Okay, we could actually use the idea of the area of the sector and area of the segment. Okay, so because this is like equally divided, okay, so each of the this part here is 120. Okay, basically we just need to find the area of one of the segment Okay, and then from there we could actually like multiply by 3 to actually get the area of this the whole triangle here. Okay, so it's to use the area of the segment. So from here we already know that the radius is 40 set 40, right? Okay, it's a set 40. So to find the area of a segment, which is like say PCR, okay, so the area of segment PCR, okay, so nice one, the name is half r square. So the r is set 40 square. Theta here is 120 degree, right? But we when we use a circular measure, we need to use the radian for that. So theta minus sine theta. Okay. So we're actually getting like, okay, when we actually square this is 20, and then we have got like, this is 2 pi over 3 minus, so sine 2 pi over 3 is actually a sec 3 over 2. So basically the whole area of the triangle PQR is just 3 times of this. Which is like 60, and then we've got like 2 pi over 3 minus 3 over 2, which you can actually simplify that if you want, so you get 40 pi minus 30 3 from there. Okay, I guess this is one of the possible way for us to actually like find the area of the triangle here without doing much work from there. Okay. The challenging part here is because the Q and R is actually not known here. So we actually have to rely on some other technique for us to actually find this area here. Okay. So you can see the questions are actually like quite creative here, where the way they actually ask the questions. Okay. Okay. So last question before we end for this. So the line, okay, y is equals to 2x plus 5 intersect the circle with this equation at a and b. Find coordinates of a and b in set form and hence find the exact length of the chord AB. Okay, so what we have is they already said about the intersection, right? So it is to actually sum in, okay, the y into the equation of the circle there and just try to find what is the extent. Okay, so with the this we actually have got the okay, we just have to like expand it. Wait, okay, 25. So that is 5x squared plus a 20x plus a 5 is 0. X squared plus a 4x plus a 1 is a 0. Okay, I see why already. So what we have for this is that, okay, we have to complete the square a little bit. Wait, this is a okay, yeah, I thought it's a complex root. So the x here is a -2 plus minus a sec 3. So correct me if I actually make any mistake in the middle of the steps here, yeah. Okay, so with this x, okay, of course we actually got to find out the y coordinate. So this one, okay, we have x is -2 plus sec 3. So the y here is 2 times a -2 plus a sec 3 plus 5. So for this, we actually get 1 plus a 2 sec 3. Okay, -2 minus a sec 3 for the x here. So the y here is 2, -2 minus sec 3 plus 5. So this is a 1 minus 2 sec 3. So the coordinates, okay, we want to find out what are the coordinates there. So just list out. Okay, so these are the coordinates of the A and B, and hence, okay, find the exact length of the chord AB here. So we really have to like find out, okay, the length of the chord AB here. So it's to use the distance formula. So just be careful about that. So -2 plus the third 3 minus the -2 minus the third 3 square plus, okay, this is a 1 plus a 2 third 3 minus 1 minus 2 third 3 square. Okay, so be really careful on working on that. This is a 2 third 3 square because the minus 2 will actually get cancelled off. The second one will be a 4 third 3 square. Okay, I think finally it will actually come up quite something nice. This is a 4 times 3, 12. This is a 16 times 3, 48. So it's a third 60. Okay, so that is the exact length of the AB here. This is the whole process then. By doing this, how many marks do we get? It's a 7 marks. So it's quite rare, yeah, I would say, that they actually ask us to work with like the exact form of like the third form, and somehow we need to square everything then. Okay, it's quite rare, yeah. You just have to be more aware and careful, okay, when you do this question here. Okay. Do I actually be able to factorize it? Okay, can I do this? Okay, yeah, 250. Okay, so what we can do, okay, in the next part there. So we actually have the part B, okay. So a straight line through this point, okay, which is a tan 0 with gradient m is a tangent to the circle. So find two possible values of the m. Okay, so what is actually happening in this case here? Okay, is they tells us that there is a line that passes through the point this tan 0, and then the gradient is actually an m. So it already gave us a point, and it tells us that the gradient is an m here. So that is where we need to form the tangent line first, okay, in terms of the m. So which is like y minus y1 is equals to m x minus x1. This is the tangent line. So if this is a tangent line to the circle, it means that it will only touch the circle at one point, or in other words is that when we actually substitute this y into the equation of the circle that we have earlier, it should only has one real root. One root, because it is just touching the circle there. Okay, so we substitute this into the equation of the circle earlier, x squared plus y squared is equal to 30. To 30 or 20, okay, 20. So after that is a series of like expanding, but here you just have to be more careful about it. M squared x squared minus a 20 m squared x plus a 100, sorry, m squared equals to 20. So you have got to tidy up this one. M squared plus 1 x squared. For the x, it's just 20, m squared. This is 100 m squared minus a 20 equals to 0. So since it is a tangent to the circle there, so we will have the b squared minus 4ac is equals to 0. Okay, so we get negative 20 m squared squared minus 4ac is equals to 0. Okay, so this is the part. 400 m power 4 minus, okay, we really have to do this carefully, yeah. So we get 4m squared, so we get 400 m power 4, and we have got 80 m squared, and minus 400 m squared, and then the last term is a plus of 80 is equals to 0. So it's not too bad that we're actually getting like this is negative 320 m squared plus an 80 is equals to 0. Okay, which is the m squared is actually a 1 over 4. So the m here is a plus minus 1 over 2.